Hi, in this one we're going to be talking about data structures in Python. So first off, let's understand what is a data structure. Very simply put, a data structure is a structure that holds data. Let's take a look at this with a more sense that pertains to our daily lives. Now, we all have a bedside table or like a chest of drawers in our home. And this chest of drawers always has many levels of drawers. It could have 3, 4, 5, 6, 7, and sometimes even more levels of drawers. Each level of drawers in this chest of drawers holds some kind of things, or it stores some kind of daily items that we'd want to access or use in our everyday lives, right? So why do we use this chest of drawers, or why do we use this bedside table? We use it so that we can find these things that we need on a daily basis easily, and we know where they're kept. So for ease of access, right? Just like that, when we want to show information in a much better and readable manner, we'd create a table containing that information on a software like Microsoft Word so that anyone reading that report that we're possibly creating understands the data that we're trying to show in a much more readable and a much more structured sense. Both of these are like data structures in our daily lives, or that we use in our daily lives. So what Python does is it offers us data structures as programmers to be able to store data that we use in our programs in a much more accessible manner so that we can use that data or access that data faster whenever we need it. So let's take a look at the types of data structures that we'll be taking a look at in this section. The first one is a mutable data structure, and the second one is an immutable data structure. Mutable data structure is a data structure whose value can be changed. This means that if you have a drawer or a chest of drawers with three levels, that is three drawers, and you store socks in the first level, maybe electronics in the second level, and possibly books in the third level, what happens is that you're free to remove the socks from the first level and put something entirely different in the first level, maybe some bedside snacks in the first level, right? So a mutable data structure is a data structure that allows you to change the values or its structure that are stored in it. Contrastingly, an immutable data structure is a data structure whose value cannot be changed. This means that it's a data structure whose structure, once it's created, is set and solid. It is the final structure, and you cannot change any kind of value that is stored in an immutable data structure. Some mutable data structures that we'll be going through are lists, sets, and dictionaries. And the immutable type of data structure that we'll be going through is a tuple. So let's move on and understand what are the list and set data structures. The list data structure is basically like a shelf, but imagine it as a horizontal shelf as you see on the screen. It basically stores some kind of data that you'd want to store in your program or you'd need. For example, if you're making like a to-do list, you could use a list and or you could use a list data structure and well store all the to-dos as strings as the items of this list. Now, for the sake of this example, let's just take this list data structure that we have in front of us and move ahead and learn what is the list data structure. Now, as you see on the screen, to position or to determine the position of each item in a list data structure, we can have indices starting from 0 to the end of the list. Just like strings, we see that the indices of a string start from 0 and then they just keep on going until the end of the string. So for this list, the element at position 0 is going to be 120. The element at position 1 is hello, and through that to 9 is 20. Now, just like strings, you can access lists with negative indices or from the back of the list. So just like strings, as we just spoke about it, you could use the -1 index to refer to 20, -2 to 18, -3 to the hyphen, -4 to the empty space, -5 for the integer 85, and so on until -10 That is the position which stores 120, which is an integer, inside this list. Another really special thing about lists is that any type of data can be stored in lists. This means that you could store integers, booleans, floats inside a list. In fact, you could also store different data structures as an item of a list, and we'll be exploring that later in our course when we actually code out lists. So in this list, we can see that the element or the item at position 0 is 120, which is essentially an integer. The element or item at position 1 is hello, which is a string. Item at position 2 is 15.25, which is a float. Item at position 3 is true, which is a boolean, and so on. So we've already stored items with about 3 different data types inside this list, and that basically tells us that lists are a very flexible, or they're a mutable kind of data structure that help you store different types of data and also allow you to customize this data that you store in them. Now, to actually define this list in Python, you would first give this list a name. So let's give this list a name, item list, make that equal to the items in the list. So in this case, you'd use an opening square bracket followed by all the items that you'd want inside this list, or that you'd want to store inside this list, separated by a comma and, well, a closing squared bracket. It's pretty simple. To access each item inside this list, you would simply use the print statement, or to display each item inside this list, you'd use the print statement and then access each item in this list using the name of the list, which in this case is item list, and going ahead with a similar syntax from strings, which is the opening and closing square brackets, and within those you'd write the position that you want to access inside this list. So the first line we see is print item list at position 0, which is 120. Then item list at position 1 would be hello. Item list at position 8 would be 18. Item list at position -7 would be true. It's pretty simple. It's really just like strings. We'll be going ahead and actually coding out lists right after we understand sets in the next section of this video. And in the next video, we'll be going ahead and coding out lists and understanding them with a short project. Moving on to the set data structure. So a set is like a list, but it does not consider duplicate elements. This means that you could look at a set as a list. Just as you see on your screen, it is represented just as a list, but I cannot store duplicate elements, or a more accurate way to put it would be you can store duplicate elements, but they will never be considered by the set data structure. So when you go to print all the elements in a set, it would print the duplicate element only once and not 2 times or 3 times or as many number of times as the same element has been stored. We'll explore this in the next video, where we get our hands dirty with the concept of sets and the code of sets. Now again, just like lists and strings, sets can be also indexed in a similar way. So in a set, the element at position 0 would be 1, and the positions go from 0 through the end of the set. Again, just like lists, you can store any type of data in a set, but what you need to remember here or note here is that you should not store duplicate data in a set, because it really doesn't make sense. A set always is a set or a data structure that stores unique values only. So to create this set or initialize this set in Python, you would give the set a name, which in this case is simply item set. Make that equal to curly braces and then your set items. So in this case, all your set items are again just like lists, separated by commas, and then at the end it is closed by a closing curly brace. So if we just recall how we define lists in Python, we use the squared brackets, and to define sets, we use the curly brackets. Similarly, we would access the set items using the same way we would access string items or, sorry, string positions or, well, list items. In this case, you'd simply type out the name of the set, which in this case is item set, and then the position that you want to access. So print item set at position 0 would give you 1, item set at position 2 would give you, well, 2, item set at position 4 would give you 5, and item set at position -4 would give you hello. So that's pretty much about lists and sets. They're pretty similar data structures, and that's why we've clubbed them in one video. In the next one, we're going to be working on PyCharm and actually coding out lists and sets and using them in a way which makes us properly understand why these data structures exist and how we can use these data structures to our benefit as programmers. Until then, if you have any questions, just put them down in the comment section so that my team or I can get back to you and help you out in the best possible way. And well, have fun, and I'll see you in the next one.